This is part 14 in a series of videos in which I am trying to create a drop-in replacement for the cassette drive on a Fluke 9010A microsystem troubleshooter. In the previous videos I've got the prototype unit built up, it works, I've been testing it, and I've got some boards on order and some memory cards on order, and once they arrive I'll make a final, or at least what I hope is a final version, finish testing it, and then I can make these available to anyone that is interested. This is an extra video that I hadn't originally intended to make, and the reason that I decided to post it is because something fairly interesting came up while I was testing this unit. And one thing I keep going on about with my channel is trying to encourage good engineering, and a major part of that is very thorough testing of anything that's designed, and this is quite a good example as to why that's so important. As I say, something very strange started happening when I was testing this, so I'll show you what the unit's doing. I'll boot up the Fluke. As ever, apologies for the flicker. I've got the cassette drive set to a particular bank that doesn't have a great amount of data in it. There's a few hundred bytes of data, and if I try and read that bank, you can see it reads that just fine. If we now try and write, it writes that just fine, and it works fine. What I've been doing is going through testing all the different banks, different amounts of data, different types of program. But what I found was when I got beyond about 4,000 bytes of data that were being stored, so you have access to about 10k of data for the programs, and then there's about another 2k that's used for storing the system settings as well, and it always stores there irrespective of what programs you have in the unit. So I've selected a bank that has around 10k of programs in it, and if I now try and read that bank, you see it's starting to read, but it's come up with a fail. So we'll try this again, and again it's come up with a fail. So I'll try another bank that again has about 10k of programs, and this time it's caused the Fluke to reboot itself. So we'll try that again. So obviously something's not quite right with this, and although it worked fine and was 100% reliable as long as no more than about 3,600 bytes of data were being saved, I really don't like leaving things like that. Firstly, I want to know what's causing the problem, but also of course it would be nice to correct it. So after spending quite a bit of time looking at this and trying to figure out what was going on, obviously I was looking at my own unit, and I was trying to figure out what I'd done wrong with the either the hardware design or the firmware, and I couldn't find anything wrong with it at all. And what it comes down to is there's something in the firmware in the Fluke that is kind of a bug, but I'm assuming it's something that Fluke knew about and just it didn't matter when it was using a cassette drive. So what I'll do, I'll just get the Fluke out of the way and then briefly explain what's going on here and what's causing the problem, and then I can demonstrate the solution to this issue. Okay, so looking around, what's causing the issue is when I looked at the Fluke board itself, I realised that the watchdog timer was being triggered during the read of data. And it turns out, so after digging through the firmware in the Fluke and putting the logic analyzer on the system and a bit of head scratching, I finally figured out what was going on. And what we have is the interface is obviously a bidirectional interface. We have data flowing from our cassette drive, so if we say our cassette drive is on the right, and then we have the Fluke on the left, then of course we have data flowing to the Fluke from the cassette drive, and we also have data flowing the other way. So the way that this works is when the Fluke writes data into the interface, it sets a flag. So it will write some data into the interface, and it then sets a little flag to indicate to the cassette drive that data is available. When the cassette drive reads the data, it sets the flag back down to off, a bit like the flags you see on the US post boxes. And setting the flag back to off indicates to the Fluke that the data has been read, and then the Fluke is free to load more data into it. And we do the same thing with the cassette drive. When the cassette drive puts data into the buffer, it sets a flag, and then once the Fluke has read the data, it sets the flag to off to let the cassette drive know that it's free to put more data into the buffer. So it's kind of like a two-way semaphore system, and this is to make sure that both sides have time to deal with any data that's being transferred. And of course this needs to be done because the Fluke expects this cassette drive to be very slow. It's a mechanical device, so normally it takes several milliseconds to retrieve each byte of data from the cassette. So normally this interface will be talking to an actual cassette drive, which is obviously quite slow. But we're talking to a memory device, so our memory device is very much faster. And so what's happening here is when the Fluke is trying to read data from the cassette drive, it reads the data from the outgoing buffer, and then rather than waiting until it's finished processing that, it immediately sets the flag back to off, even though it hasn't processed the data. And presumably it's doing this because the designers assumed that, well, this is a cassette drive, so it's always going to be several milliseconds before it's going to put the next data byte into the buffer. So this will save time down the road. When the Fluke comes back to read the next data byte, it will already be there. It won't need to then set the flag and then wait for the cassette drive to load the data. The problem is, of course, because we're now running the system so much faster, is when the Fluke reads the data and then immediately sets the flag to off, it goes away to start processing the data, and it comes back periodically to see if the flag's been reset and if new data is available. But normally it would have several thousand iterations of that loop before data is available. But because we're loading data so quickly, it doesn't have enough time to finish processing the last byte that it read, and it has to immediately handle the next byte. And so presumably whatever's going on within the firmware is not giving the Fluke main board time to process the data that it's reading, and that's kicking off the watchdog timer. Presumably it's dropping certain crucial parts of the loop, and it's not getting round to resetting the watchdog timer. And once it's alright for a few hundred or a few thousand bytes, but then eventually this time catches up with it and it runs out of time to process data, and then effectively the system crashes. So once I'd figured that out, all I've done is to put periodic delays in the outgoing data stream. So what it will do is every now and again it will just put a halt cycle into the data stream. It does not slow down the overall process because the Fluke is merely catching up in those periods. It's not actually causing a delay in the transfer of data. And the same when it's writing data to the memory. The bottleneck is now the Fluke. Our memory system is actually waiting about 85% of the time for the Fluke to deposit data into the buffer. So in other words, there's no point us going to faster memory. Somebody asked about memory type, and this is an I2C memory. We don't need SPI or anything fast because we're already at the point where the Fluke is the dominant factor in the speed of transfer. Even more so when it's reading data. In fact, we'll demonstrate the unit now, and you'll notice that the read portion of a write cycle is now longer than the actual write part of it, even though writing to one of these memory chips is quite slow. So I'll modify the Fluke to build in this delay wait states, get the Fluke back on the bench, and then I'll demonstrate it to show that it has cured the problem. Okay, so I now have the modified firmware that includes the additional wait states. We'll power up the Fluke. And now what I can do is we can try rereading the memory card. This does have around 10k of data, so it does take a few seconds to read. Okay, so that's finished. As you can see, the Fluke's quite happy. If we look at the programs stored, you'll see that there are a lot of programs stored in this memory unit at the moment. And if we select one of them, you'll see that there are some quite large programs in there as well. And in fact, we only have 5 bytes of memory left. So this is a full complement of data for the Fluke. This holds the maximum allowable amount of data. And if we now try and write that data back to the card, you can see the red LED is on. Let's now switch to verify. So you can see now why I wanted to speed this up. It would take a very long time if we weren't writing data at a fairly reasonable rate. And as you can see, it's successfully completed the write. We'll read this back and we should still have all the programs intact. So each bank on this will support up to 100 programs, and because we have 8 banks, it means that a single card without the external memory cards can hold up to 800 programs, and each memory card will hold an additional 800 programs. So this is a very capable unit. So let's finish reading, and again you can see that all the data is indeed intact. And the beauty of this is, although we've got a lot of data in here, if we now cycle the Fluke off, normally all that would be lost. And if you had an RS-232 interface, then of course you could use that with the PC to download the data. But the advantage of this is it's standalone, and you can easily transfer the memory cards from one machine to another. We can very quickly read the data following a power up, and so within probably 10 seconds of power up you can have up to 100 programs available and ready to go within the Fluke. So obviously much more useful than the tape drives. Even if you have the RS-232, that's still a bit of a pain. Also, what you can do, of course, is switch the write protection on. So I've now got this set for write protect, so we can still read the tape when that's on. So it's reading the data, and that's now read. But if you try and write with the write protect on, then you'll get this write protected message. It just stops you overwriting if you don't want to. It works slightly differently with external cards. The third switch along is to select the external memory card, and if you select the external memory card, then the write protect is on the individual memory cards. So there's a little jumper on there you can set on the memory card to put it into write protect mode, rather than using this switch. This switch is just for the internal memory, and it means that you can have your memory cards individually write protected. So if you've got a library of cards, for example, the best way to use them is to write protect them once you've got the data, plug them into the Fluke, copy the contents into memory, and then if you want to retain that through multiple sessions, just save that back into the internal memory. Okay, but as you can see, the issue with it rebooting itself during long reads has been dealt with. I have checked this a lot, and it is 100% fixed. It's now 100% reliable. It's not flaky in any way. It works absolutely as it's supposed to. And this is really why I went to the time and trouble of tracking down exactly what was going on. I don't like workarounds or guessing at things. I don't even like fixing problems if I don't know why the fix worked. But here I identified what the problem was, put in the solution that I knew would work and why it worked, and it's resulted in a 100% reliable system. And that's the approach I recommend. Is no point just guessing at things. You need to understand fully what is going on in order to best deal with the issue. Incidentally, this long time, it's taking about 10 seconds, 12 seconds to read the card. That's simply because it is totally full. If I select a bank that has a more typical amount of data, so this just has 1,000 bytes or so, and read this bank, you see that it only takes a second or two. And the same with the writes. If we try and write this data back to the memory, you'll see that it only takes a few seconds. I do of course need to turn write protect off, as it won't work. And as you can see, it just takes a couple of seconds. So if you got maybe 30 or 40 programs, then it's very convenient. Just takes 2 or 3 seconds and you're ready to go. Okay, I thought you might find that interesting. I haven't finished testing yet. I've got a lot more testing, but this is the approach I take. If I find something wrong, then I fully investigate it, find out what's causing it, and then put in place a proper solution. And the idea is to end up with a unit that is fairly bulletproof. Nothing more irritating with test gear than test gear that is itself flaky. You end up never knowing if the fault you're looking at is your test gear or the unit you're trying to repair. So I need things like this to be 100% reliable.